Hello friends, today we will see how to prepare the data to train object detection model using SageMaker's inbuilt algorithm. Now, preparing the data for object detection is much more involved compared to the classification because we have these objects and the bounding box coordinates, also the image dimensions, etc. Right? For classification, it's simply an image and a tag. Even for multi-label classification, we can have multiple labels, but that's about it. Whereas for object detection, we need much more information like the image dimensions, the bounding boxes and their coordinates, etc. Okay. So to begin with, we have all the images here, and we generally use an image annotation tool to create the labels. Okay. So in this case, I have used Make Sense. It's a free and open source browser based tool for annotating the images. Okay. So I have used that tool and I have already annotated the images. Okay. Now I have a separate video series using Make Sense. Please watch those videos if you don't know how to create the ground truth. Okay. So we take this as an input and we want to create the annotations or the ground truth in this format. So unlike image classification, for object detection, some models expect one annotation or one JSON file per image, or some other models, all this information can be within one file. Okay. But for the SageMaker's inbuilt SSD model, it expect one JSON file per each image. Okay. Now the format of JSON file, it looks like this. Let's look on VS Code because we can format it. Okay. So this is how the JSON file should look like. Okay. Now it contains 4 sections. So the first one is this file, which is simply the image name. Okay. And the second one, the image size. This is a list, but with only one element, and that element is a dictionary with 3 values or 3 key pairs. Okay. So the image width, the image height, and the depth. So for color images, this value is 3, always 3. Okay. So that's image size. And then we have the annotations or the bounding boxes information. Now this is again a list. The number of elements depends on how many objects we have. For example, in this case, this image, it has 2 objects. Okay. So the first object is this one and the second object is this one. Now each object we identify with 4 coordinates, right? Using the top left coordinate and then the bounding box width and height. Okay. Now different algorithms or models takes this exact information in different format. For example, in addition to this top left coordinate, we can have bottom right coordinate, right? Instead of the width and height, we can have the bottom right coordinate. So those 4 values also are enough to infer the box coordinates, right? Or we can have the top left coordinate along with the width and height of the bounding box. Okay. So, and for each box, we have the class ID. Okay. Because an image can contain multiple objects and these multiple objects belonging to different classes. Okay. And this is for the second object. Again, we have the 4 coordinates and also the class ID. And then finally the fourth section, which is this categories. Okay. So it's supposed to, it contains the mapping between the class ID to the class name. Okay. Now what I noticed is this categories information, it can contain all the labels and their IDs. It don't need to contain only the categories or the objects this image has, right? For example, in this project, we have 3 labels, right? For example, we can have uh, like this. For example, this one, which is this orange. Okay, so even though this image does not contain an orange, the categories list can contain all the categories of this project. Okay, that's what I noticed when I trained the model. So what this means is probably this categories information is not really used during the training, or maybe it simply ignore this additional information we have for that image. Okay. All right. So let's go back to the code. Okay. So quickly, we are going to use this file, which is the output from Make Sense, to create a number of files, one for each image, in the form of this JSON files. Okay. So all our images and the labels file are again in this all images and ground truth folder. We are going to create these 4 folders, and we are going to create all these JSON files. Okay. And then we are also going to create this mapping file. Okay. So let's get into the code. Now here we are creating the 4 folders, and then reading the output or the objects from the Make Sense. Okay. Now this file contains 8 columns. Now unlike image classification annotations, for object detections, the Make Sense output contains the column headers. Okay. So we don't need to provide the column headers. So it has, okay, let's start with this image. Okay. So we have the image name, and then the image width and height. Okay. And then finally, for each image, we will have the object, the label or the object name, which is one of these 3 in this project. And then we have the box coordinates in the form of this box X and Y. So this is referring to top left coordinate. So the X is left, okay, Y is top, and then the box width and height. All right. So here we have figured out how many images we want to use for training and validation. And here we have created this mapping file to map the classes to the class IDs. Okay. Now, so we are going to use this label name column to find out or to map it to class ID. Okay. So using this mapping. So here we have simply created this additional column where we have the mapping between the class name to the class ID. And then as we saw from this JSON file, it expects these keywords like left, top, width, height, class ID, etc. Right? So for convenience, what we are doing here is we are converting these 4 names, this bounding box X, bounding box Y, and then this bounding box width and height, to simply left, top, width and height. Okay, so that we can create this file a bit more easily. All right, so we have simply renamed the columns. So using the pandas rename function, and we want to rename the columns because we need to explicitly state this is columns, otherwise it expect it to be index or rows. Okay, so this is the columns map. Okay, so all we did is we simply transform these 4 column names to these 4 column names. Okay, all right. And then so we want to first, let's create this category section, which is the easy part, right? With this category section, as we discussed, maybe I'll show on the here. So as we discussed, this is generic and it can contain all the categories. Okay, so let's create that first. Okay, so using this labels map file, we simply created this categories just in the form of the SageMaker expectation, right? The ground truth format. So we have the class ID and the name. That's for label one, and then we have second element and we have the third element. Okay, so we have created this categories part. So out of these four sections, we have created this generic one categories. Okay, now as I said, it's a bit involved compared to classification, but again it's not difficult. Okay, so first let's access all the images. Okay, so from the data frame, using unique, we are getting all the image names in the form of a list. Now the reason we are using unique is because unlike classification, the number of rows can be more than the number of images, right? For example, even though we have only 100 images, the number of objects is 161. So the number of rows is also 161. For example, okay, this image, it contained two objects. Okay, whereas this image, it contained these three objects. Okay, so that's the reason we are using unique here. Okay, so we have collected all the image names. Now we are going to create one JSON file per image, right? Not per object. So we are looping over all the images. Okay. Now this data frame, it contains the data about all the images. But now we are creating this temporary data frame called image data frame. Okay. By simply uh, uh, filtering out, right? By simply, so we are using this image name from the original data frame, and if this image name is equal to our selection image, then we are subsetting or filtering this data frame. Okay, so now this data frame contain only rows related to this particular image. All right, now let's create the second section, right? Now let's create this image section of the ground truth. Okay, so it contains three elements: the image width, height, and the depth. So let's get back here. Now we are creating the image section. Okay, so as we discussed, it's a list with only one element, and it has these three values, right? It's again that one element is a dictionary, and this dictionary contain the width of the image, height of the image, and the depth. Now the width of the image, so here we have this image data frame. So from this image data frame, we have the image width. So we have the image width. Now if this image contain multiple objects, what we get here is multiple rows, right? But the image width and height are not going to change for the object. These are sort of global, right? These are image properties, not object properties. Okay, so that's why we are simply saying, okay, my first row, so get me the value from the first row, because for the second row, if it contain two objects, the values still be the same, right? Because these are image properties. Now this int, just to make sure, sometimes when we read data from files, it's read as floats, etc. So this is just a safety. Okay, so here we have collected the image level properties, which are this image size. Okay, so the second one is also done. So earlier we have defined the categories, and then for each image, now we have defined the image. Now the main part, this annotations part. Okay, so let's go here. Now we are choosing the annotations, right? Now these annotations can be multiple for each image, right? So here what we are doing is from this image data frame, we are selecting these 5 columns. Okay, so the 4 related to the object dimensions, and the first one the object ID or the class ID, right? So here we are selecting this column, the class ID, and then the 4 columns related to that object. Okay. Now this can contain multiple rows, right? Because if an image can contain multiple objects, but we have a convenient uh, pandas functionality, which is this to dict. Okay, so we can convert a data frame to dict with orient as records. So what this does is it automatically convert the data frame to this format, right? So the exact format we want it. Okay, so we have the annotations as well. Okay, now finally, so these annotations again are just reiterating, this can be multiple records. Okay, so this will be a list with as many dictionaries as the number of objects. All right, finally we are preparing this ground truth dictionary with the 4 elements. So the first one is the file, the image size, which we computed for image, and then the annotations part, and finally the categories, which we made it generic, right? So this categories, it's going to contain all the categories, whether this particular image contain that category or not. And as I said, object detection algorithm, it's fine with it. Okay, I don't know if that is intentional or not from SageMaker, but the generic or the full information is also working. All right, so we have prepared the content of this file. Now we need to write that file. Okay, now in this part, what we are doing is we want to divide the data into train and test, right? We want 70% of the data to go as train and the rest 30% should go to validation. So what we are doing here is we are generating a random number using that random library from Python. Of course, all these libraries are from Python. So this value will be between 0 to 1, and all the values are uniformly sampled between 0 to 1. Okay, so what we are doing is, if this value is below 7, now I want to go that image to the training part. If that value is above 0.7 or equal to or above 0.7, so this is this else part, we want that image to go into the validation part. Okay, all right, so let's say the random number we generated happened to be below 0.7. So that means we need to copy the image to the train images folder, right? So from this source directory, all images and ground truth, which is this one, where we have all the images and all the output from Make Sense. So we move the file to the train images, or we simply copy the image, right? And then corresponding to that image, we need to create the annotation file or the JSON file, right? So train images, okay, this file, train annotation, yeah. So this JSON file. So what we are doing is we have created a JSON name. So this file should go to train annotations, and then this file name should be the same as the image name, except that it should have the .json extension. Okay, so what we did is we took the image name, we split the image name using dot. So for example, if the image name is so and so, where is it? So and so dot JPG or PNG, etc. So we split it using this dot. So that gets split into 2 elements. So the first element contains the image name and the second element contains the extension. Okay. So we took the first element, so which means we took the image name without extension, and here we are adding the JSON extension and then writing to the file. So this file, it will be going to this train annotations with name same as the image but with extension JSON. Okay, so we have written the file to the annotations folder. Okay, same thing we are doing here, but if the random seed is below 0.7, we are doing it for the validations folders, the images and the annotations. Okay, here I'm just showing you one example of this ground truth dictionaries we have created here. So this one, right? So the ground truth dictionary we have created, that's for the last image. Okay, so it contains 4 sections as we discussed. First, the file name, and the second one, the image size attributes, the width, height and depth, and the next one, the annotations. This is again a list and each element is a dictionary, and the number of elements is equal to the number of objects the image has. So in this case, this one happened to have 2 objects, and each object will have these 5 sets of information. The first one is the ID, and the remaining 4 are the coordinates to identify the bounding box. Okay, and finally we have the categories, which is, as we have discussed, can be generic, so it contain all the categories. Okay, so that's the 4th element. All right, again in summary, we have started with this all images and ground truth folder and a labels file created using make sense, which look like this. Okay, which sorry, is it this one? Yeah, that's the one. So which look like this. So for each image we'll have the labels and the bounding box coordinates. Okay, and also the image dimensions. So we took that as an input, and then we have created these 4 folders and a mapping file, copy the images to the corresponding folders, and then for each image we have created one JSON file, and the JSON file in this format we just discussed. Okay, so using this data prepared, now we can train an object detection model using SageMaker's inbuilt algorithm. Okay, now as you know, there are hundreds of different object detection models. Now different models take the data or the ground truth in different format. So they still contain the same information, but in maybe slightly different format, right? So in the next video, we will see how to prepare the data to train a TensorFlow model using the Jumpstart. Okay, so the format will be slightly different. We will do that in the next video. Thank you very much.